In this video, we're going to talk briefly about domain. So domain. So the domain of a function is the set of all inputs. So the domain, it's basically the set of all inputs. Set of all inputs. Okay, it's the set of all inputs for our functions. And we're mainly concerned with two types of functions. So we're concerned with rational functions. So rational functions. Rational functions are functions that are fractions. So for example, 1 over x plus 2, 1 over x minus 7. And we're also concerned with square root functions. So square root functions. Square root functions. Stuff like square root of x minus 3 or square root of x plus square root of x minus 7. Okay. So we're looking for all the numbers that we can plug into these types of functions. Now, in this first example here, the rational functions, you can plug in any number you like except the numbers that make the denominator 0. So for example, here you can plug in everything except negative 2. Here you can plug in everything except 7, because 7 minus 7 is 0. So you're not allowed to have 1 over 0. Okay, so whenever we were finding the domain for rational functions, we always just start by setting the bottom equal to 0 to find out what numbers to throw away. Now, square root functions, one way to think about it is you can't take the square root of a negative number. So whatever's in the square root has to be greater than or equal to 0. So same thing here. This piece here has to be greater than or equal to 0. And this piece here has to be greater than or equal to 0 because it can't be negative. So if it can't be negative, it's 0 or it's positive. That's the same thing as saying greater than or equal to 0. So for fractions, the bottom can't be 0. For square roots, whatever's in the square root has to be greater than or equal to 0. So let's go ahead and do a bunch of examples. So the questions will all say, find the domain. So find domain. Say we have f of x equals 1 over x minus 2. So here we have a fraction, and so we know that the bottom can't be 0. So obviously it can't be negative 2. Or rather, it can't be 2. But if it's not obvious, what you can do is you can set the bottom equal to 0 and solve. Always, no matter what. So whenever you have a fraction, just take the bottom and set it equal to 0. And so we get 2. So the domain is everything except 2. So there's a couple ways to write this. Method 1 is to use what's called set builder notation. So it's the set of all x's such that x is not equal to 2. Right? X can't be equal to 2. So that's one way to write it. The preferred way for like calculus classes is to use interval notation. So you draw a number line, you write down the 2, and you want to exclude the 2. So the domain is all the numbers all the way up to 2, but not including it, and then starting at 2 but not including it, and then all of these numbers as well. So it would be negative infinity all the way to 2, union, and then 2 to infinity. See how I got that from the picture? Negative infinity all the way to 2, parentheses, union. So you put a union to connect these, and then parentheses, 2 to infinity, 2 to infinity. So this is the interval notation answer. So this is set builder, this is interval. B. Say we have g of x equals the square root of x plus 4. So in this case, we have a square root function. So whatever's in the square root can't be negative. So it has to be 0 or positive. So the first step is you take this and you set it greater than or equal to 0. Always. So whenever you have a square root, just take whatever's in that square root and set it greater than or equal to 0. Then you solve for x, so x is greater than or equal to negative 4, because we subtracted 4. So in set builder, it would be x such that x is greater than or equal to negative 4. That's the set builder notation answer, right? In interval notation, here's the negative 4, and it's all the numbers bigger than negative 4. So all of these guys over here, all of these. So bracket negative 4 to infinity. And we use a bracket in this case because we include the negative 4, right? It could be equal to negative 4. That's what the bracket means, right? So whenever you have a fraction, you just hit the bottom equal to 0, and that tells you what to throw away. whenever you have a square root, you just take whatever's in the root and you set it greater than or equal to 0. In the videos that follow, you'll have plenty more examples. I hope that made sense.